I'll remember this. All right, so today we're going to talk about transformation. How do transformations affect lines and shapes? Our learning goal today is to understand the effects of transformations. We're going to be talking about transformations, reflections, pre-image, rotation, image, translations, and the thing called isometry or stuff. What is transformation? Transformation is a change in the position, size, or shape of the figure. The original figure is called the pre-image. The resulting figure is called the image. Okay? We'll talk more about it in just a second to make sure we've got all this stuff down. Okay? Transformation means that we are pretty much going to, let's just call it shift. Okay? Either line segment, most of the time it'll be a shape from one point to another. Okay. Typically, all of our transformations are going to be on a coordinate plane. We'll deal with that here in just a little bit. Right? Let's make sure we understand this part. The pre-image is indicated by capital letters. Pre-image, triangle, A, B, C. Okay. This arrow tells me that it's being transformed into this image, A prime, B prime, C prime. See the apostrophes? A prime, B prime, C prime. Okay? So this is before the transformation. This is after the transformation. All right? That's how I know what's going on in the transformation. Okay? Okay, good. All right? Let's just start. Anybody writing this down still? We'll wait on it. All right, guys, the next slide will tell you the three types of transformation we're going to be talking about in this unit. You need to write down everything on this slide. Okay? We first have a reflection. And I will tell you the trigger word that goes with each of these. A reflection is simply a flip. And it is a flip across a line that we call the line of reflection. Each point and its image are the same distance from the line of reflection. So this would be a reflection from ABC across the y-axis to A prime, B prime, C prime. A flip across the y-axis. Rotation is a turn about a point P called the center of rotation. Each point and its image are the same distance from point P. So the center of rotation, if you will, is where the hinge of the rotation occurs. Then we have a translation or a slide. And that's where we slide all the points of the figure in the same distance and the same direction. So if we're going to translate something, we'll translate left to right, up or down. Everything translates left. Everything translates right. Everything translates up, or everything translates down. What's the combination of it? Make sure, and I mean make sure, that you've got at least the understanding of the particular transformation with the words in blue. That's circled in blue. Okay? So when I say a reflection, what do you think? Flip. When I say a rotation. When I say a translation. This. Okay? Flip one, turn one, slide one. Right? Make sure you got that part written down. Break if you need the slide again. Okay? All right. What happened here? What transformation took place? Okay, what? Rotation, okay? It's a rotation. And what trigger word do we have with rotation? Turn, right? So triangle ABC, turn 90 degrees counterclockwise. Counterclockwise. Clockwise. Right? If you ever get stuck with that, you can look at my clock. It hasn't moved in 3.5 years here, so but you know, the thing, the clock would turn to the right, counterclockwise would go to the left. Okay? right, here we go. What happened here? What do we have? A what? Okay, who says translation? Who says reflection? Who says rotation? Good. No, you're wrong. I know, I just got you. All right, check it out. Why? Hey, check it out. How can I tell if it's a translation or a reflection? Yes, sir. The points. What about the points? Yeah. If it's a reflection, you see how DE is at the top of this rectangle? It'll flip and now be in the bottom of the rectangle. A translation would merely shift down. Okay? That's the difference. Do I get that? Okay. This is called check it out, this is a reflection across the x-axis. Oh, Sensei, across the x-axis. Okay? All right. You don't have to, we're not going to do the class lab thing, but what happened here? Translation. Okay? It's a translation. I moved MNOP to the right and down, right? I shifted it to the right and down, or slid it to the right and down, right? So those are our big transformations in this unit. We're going to add one more. We'll add dilation, but it's not until the second unit, okay? So right now, that's what you need to know. All right. This is an important slide. I would say you definitely have to write down what I'm going to underline in red, and you may write down the rest if you want to get an A or a B. Okay? An isometry, or isometry, I think it's isometry, is a transformation that does not change the shape or size of a figure. Reflections, translations, and rotations are all isometries. Isometries or isometries are also called congruence transformations or rigid motions. Right. We have a big deal about this whole unit that you understand the following. Whenever I have an isometry, which is what we've been talking about so far, right? Translation, or reflection, or rotation. Here's what that means. That means that my shape in the pre-image, after it goes through the transformation, any of those three transformations that I just said, after it goes through the transformation, it has the exact same shape and the same size as it did before. Okay? That's a big deal that you understand that. We call that a congruent transformation or a rigid motion. Okay? Congruent transformation or rigid motion. Right? And I think hopefully you've seen this, okay? You saw the fact that each of these shapes had the same shape and size as they went through their transformations. Fair enough? Okay? That's the unit. The unit is focused on whether you understand that any type of rotation, reflection, and translation means that the shape maintains its size, beginning and end. Okay? It'll change when we do a dilation or a stretch. That's when we make something bigger or smaller. Okay? And it has the same shape, but a new size. That's not a rigid transformation or a congruent transformation. Okay? All right. You don't have to write this down. Let's read this slide. Find the coordinates of the image of a figure in a translation. Just talking about, this is just talking about translation. And A to the x coordinates of the pre-image, and B to the y coordinates of the pre-image. Translation should also be described by a rule such as. Here's the big rule. Take your coordinates, your pre-image coordinates, x, y, whatever the coordinates are. -4, 5. 1, 0. 3, -6. Okay? Take those coordinates for your shapes. And for each coordinate, you will either add A or subtract A. You'll add 5. You'll subtract 2. You'll add B or subtract B. Add 7. Subtract 6. Right? You'll have your coordinates A, B, and C. Add 3 for all the X values. Subtract 4 for all the Y values. And you'll get A prime, B prime, C prime. Okay? Let me show you an example before I cut you loose today. All right, here we go. Here's an example of a translation that you're going to see today. Find the coordinates for the image of triangle ABC after the translation, X, Y, such that. I add 2 to the X coordinates and I subtract 1 from the Y coordinates, draw the image. The answer is on the board. Here it starts, there it is. How do we get the answer? Right? Okay, here we go. I've got a triangle, 3 points, A, B, and C. What are the coordinate points of A on this triangle? -4, 2. Very good. -4, 2. What are the coordinate points of B? -3, 4. What are the coordinate points of C? -1, 1. Perfect. Now understand something. All I've done right there is this step right here, right? I've just defined my X and Y for each of these 3 coordinate points. Okay? That's all that I've done. If you're looking at it this way, I'm just sitting at this point. We will apply to each of these coordinate points the following transformation. We'll add 2 to the X, subtract 1 from the Y. Add 2, subtract 1. Add 2, subtract 1. And that will result in A prime, B prime, and C prime. Okay? Miss Leffler, what is -4 plus 2? Miss Leffler, what is 2 minus 1? So A prime should be at -2, 1. Okay? Man yawning in the back. Good. -3 plus 2 is what? Good. -1. What is 4 minus 1? Good. Okay, so B should be at the point -1, 3. What is -1 plus 2? Good. What is 1 minus 1? Yeah, that one is easy. Okay. So C prime should be at 1, 0. Right? After I have plotted these points, I will have both a free image and an image. That tells me the transformation that took place. That's a translation, guys. I translated 2 units to the right and 1 unit down. Okay? Everybody see that? Pretty simple, right? Pretty straightforward.